So today we are beginning on Unit 4. So Unit 4 is all about bonds. So we're finally going to get into the details of how things like compounds are formed. To start with that, we're going to do a little bit of review and then kind of enhance our understanding of ions. 4.01 is about monatomic ions. So by the end of this, you should be able to explain what a monatomic ion is, as well as predict what kind of ion anything from the group A columns on the periodic table will form. Alright, so do a quick review on ions here. So ions have a varying number of protons and electrons. Alright, I apologize. This first sentence I'm going to rewrite. So let's ignore this. I typoed here. So ions have a different number of electrons. Alright, whereas a neutral atom, so as compared to a neutral atom, which has equal electrons and protons. Okay, so that's the key review thing there. I apologize for my typo here. So, and then just to recall how this works. So ions, the only thing that's ever changing is your number of electrons. You can either gain those electrons or lose them. When you gain electrons, we know electrons have a negative charge, so we're going to have extra negatives. So that ion will be negative when you gain electrons, and that's called an anion. All right. Whereas if you lose electrons, you give away some of those negative charge. All right, you lose some of the negative signs. You're going to end up having more protons than your electrons. So you'll be overall positive in your charge, and that's called a cation. All right, if you remember, I had that whole little cats are positive as a way to help me remember this. Cations are positive. That means that you lost electrons. And ions are negative, and that means you gained electrons. So, with this in mind, let's look over this diagram we have here. So, first thing, looking at our diagram, we want to identify 3 elements that form only one cation. Alright, so I'm going to circle some of those in green. So forming only one cation, like here. Potassium has one possible positive ion, K+. So does barium. It has one possible positive ion. It happens to have a positive charge of 2, but there's only one type of ion there. All right? So really, we're talking about these guys. You can also include silver and zinc. All right? So these elements that have only one possible form of ion that they create. It can have a +1, a +2, even a +3 charge. All right, but there's only one possible ion formed. All right. Those that only form a single anion, let's see, do those in red. All right, that is those things that form only one possible negative charge. So that's going to be everything over here. All right, so oxygen 2-, phosphorus 3-, iodine 1-. All right, these guys all have one possible ion form, and they all happen to be negative. The elements that form more than one cation, all right, circle those in blue. If you haven't kind of picked up on this yet, that's what these guys are. All right. These guys, some elements have options as far as what kind of ion they may form. All right. And if you notice, most of these, all right, and if I were to actually sit there and talk about all of these transition metals, really zinc and silver are the only transition metals that form singular ions. Almost all of them form multiple. All right, so your transition metals are weird. All right, they generally speaking have more than one ion option. All right. Another thing, and I know this isn't exactly on here, but another thing you kind of want to make note of, if you remember, we had that zigzag line here. All right, our non-metals versus our metals. Do you notice any sort of pattern going on with the charges that they form here? All right, everything to the left of that line is a metal. Metals form positive ions. Non-metals form negative ions. All right. So, kind of putting this all together. How many atoms are present in monatomic ions? Right. Typo there. All right. You should be saying 1. All right. So everything on the slide previous in that picture was just a single atom. All right. They might have more than one option, but everything in there was just a singular atom. All right. And they have an ion that they form, or maybe a couple of options of ions that they could form. All right. Metals tend to form positive ions. Non-metals tend to form negative ions. All right, so this is important as far as kind of definitions go. The other aspect of what you need to know for monatomic ions is that the group A ions have specific patterns or specific rules that they tend to follow when it comes to forming ions. All right, and we've talked about this before in Unit 3. You did that labeled periodic table, you should already have this on there. If you didn't do that labeled periodic table, you need to write this down, because the expectation of this class is that if I give you an element in a group A column, you know what kind of ion it forms. You're not going to be told that potassium forms a +1 ion. You're just going to need to know that, oh, potassium's in group 1A, everything in 1A forms a +1 ion. All right, so if you remember 1A, 2A, and these are way over on the left side of the periodic table. All right, so there's a whole bunch of the periodic table here that got chopped out, the transition metals. All right, so after the transition metals, this pattern picks back up. All right, and the pattern goes, column 1 forms +2 ions, column 2 forms +2, column 3 forms +3, column 4 is where things get a little funky, and even if you noticed it before, even as you get down here, things get even funkier. But column 4, I write as +4 and -4, because after this, everything forms negative ions, because we're getting into our nonmetals. All right, and then our noble gases, which don't react at all, don't form ions. All right, write this down, take a screenshot. You need to reference this. All right, if you're having to form an ionic compound between rubidium and bromine, you need to know that rubidium is +1 and bromine is -1. You won't be told that. The expectation is that you are going to use this. So, just a little bit of practice. All right, so use that screenshot that you just took. See if you can get these answered. I'd say pause the video here, because this is definitely something you want to be able to do. If you need to, go back, screenshot the group A ion pattern. All right, but then you're just going to go, okay, well, sodium I can see is in 1A. So that means it forms a +1 ion, so it would be Na+. All right, nitrogen is in group, it's changing tools on me here. All right, so 5A forms a -3 ion, so this would be Na-. -3. All right, chlorine is in 7A, which means it forms a -1 ion, so it'll be Cl-. You can put a 1 in there. The 1 is unnecessary, but it's not going to hurt it any. All right, barium is in 2A, which is +2, so it's going to be Ba2+. All right. If this isn't making sense, if this isn't super easy now that you have that cheat sheet from the last slide, you need to come talk to me. Okay, because this is really, really, really important.